I'm sorry to disappoint everyone, but I'm not going to be talking to you about connected TV. So if that's what you're waiting for, maybe, I don't know, make your way to the edge and you can head out. What I am going to be talking to you about is this. But first, we often believe that in order to go faster, to deliver more value quicker, you have to sacrifice quality. And in order to deliver high quality products, we have to go slower. But why do people think this? Well, for a second, let's imagine a team with a high bar for quality, say about there, and with an acceptable level of speed, say around there. Now, let's say there's some pressure from somewhere in their organization to see if the team, can deliver a little faster, just for a short while. So the people in the team work a little harder. And at first, things are pretty good. Maybe they work a little longer. Through their lunch break, stay a little later, start a little earlier. And they get faster. And the quality drops, but by an acceptable level. So no one really notices and everyone's pretty happy. Now, maybe this fictional team is congratulated for working harder, going that extra mile, pulling out all the stops, moving that little bit quicker. Maybe some team members decide to push a little harder, answer those requests for features out of hours, maybe offer advice when they're on holiday. Maybe some more requests come in from the organization to see if the team, could fulfill one more request. It'll only take a minute, just a minor tweak to the UI. This time, though, they take a teeny tiny little shortcut. Maybe they don't spend time thinking about what risk could be introduced by making that change. Maybe they don't create a ticket and run it through their team's boards like they usually do. Maybe they don't pair on the work with another developer. Maybe they don't chat with their testers on the team, see what they think about it. Maybe they skip writing the tests altogether, just to get out a bit quicker. Nothing malicious like pushing code directly to production by bypassing the build process. And the team goes a little faster. But this time, the quality drops, which a few people notice. Maybe your testers raise a few more bugs. But it's not clear if it's the fact that you're working hard or the work is actually hard to do that's caused the quality to drop. And because of that ambiguity in the situation, is it working hard or the work worked hard to do, some people decide to double down and see if they can go even faster. It's what everyone wants, the business, the users, even the team. Maybe they take even more shortcuts, skip a couple of meetings here and there, just sit on your laptop, no one will notice. Maybe they don't go to that training course on leadership or mentoring. Maybe they skim working on with the more junior members of the team. You show them next time. Maybe you brush that bug in production under the carpet. It's fixed now. No one needs to know about that. Now the team goes even faster. But this time, the quality levels have really dropped. So much so that your users are complaining more regularly. Maybe even your heads of department are now getting personal messages about the bugs from your users. It's finally dropped to an unacceptable level of quality. And you've now sacrificed speed for quality. So, how do we close the quality gap? Well, because of that ambiguity, was it because the work's hard to do, or was it because the work was hard? The obvious solution here tends to be more testing. If we can catch all the bugs before they go into production, we can surely keep our speed while also improving the quality. So, they added waiting for tests to happen. Every ticket now worked on the team must go through the testers. But the testers, well, they can't test everything. So to help them out, let's automate more of the testing that they're doing. Now, this causes quite a few other problems, but the main one for this scenario is that it's pushing testing towards the end of the development process. The problem is that as the quality goes up, the speed starts to drop, as testing starts to become the team's new bottleneck to delivery. So it's no wonder that we often see speed and quality at opposite ends of the spectrum, especially if the best way to increase the speed is by working harder. But to increase the quality, you must do more testing. But is there a way we can have both? Hello everyone, and welcome to my talk, Speed versus Quality, Can You Have Both? Now, my name is Gosai, and I work for the BBC. Now, just in case anyone hasn't heard of us, we're the British Broadcasting Corporation. And essentially, we're a public media broadcaster, which basically means we create content that goes on TV, radio, and the web, with a view to inform, educate, and entertain the British public, all of you. Now, I work on the tech side of the org, better known as the Mobile Engineering Group, which houses all of its mobile apps teams, such as iPrint Sounds, its video and audio on-demand services, as well as BBC's news, sport, and weather apps. And all of these apps are supported by dedicated multidisciplinary engineering teams, which in turn are supported by back-end teams that provide all the APIs to power these services. Now, I work as a principal tester across the entire group. And what I'm particularly interested in is establishing a culture of quality, which is one where we don't inspect for quality by testing for things at the end of the development process, but one in which we build quality in at every level that we work. From the products that we build, into the processes that we use to build those products, and into the very interactions of the people who use the processes to build the products. And I call this approach quality engineering. And if you'd like to learn more, then check out my newsletter where I talk about this and many other topics. And if you'd like to connect with me on social media, then you can get me on LinkedIn and Blue Sky as well. Now, one of the ways in which I help engineering teams is by seeing how they can do things better, faster, and cheaper. But most importantly, sustainably for those engineering teams. Now, one of the conversations I often get into with teams, inside and outside my organization, is what does speed and quality mean in software engineering? And, well, can you have both? Well, let's go back to our little hypothetical scenario from earlier. This time, instead of the pressure to work harder, the ask is going to be to work smarter. How? Well, by not directly focusing on speed or quality, but our capability to do the work. And specifically, to improve it using experimentation, to encourage trying things out and seeing what does and doesn't work. Now, this is where things can sometimes get a little bit derailed. See, when you start working on improving your capability, there's a good chance that instability is introduced into your existing process. And your speed and quality, or both, as in this case, can drop. Now, usually this is where the derailing happens, as people panic. If you're trying to improve your capability and all of a sudden your speed or quality drops, it can seem counterintuitive. You're trying to get better, not worse. Now, what happens here is that panic leads people to stopping the improvement process, going back to the existing process and suggestions obey, maybe now is not the right time, maybe next quarter will be better. What I would say is that what we need to do is improve our ability to learn from failure. And that rather than only trying to mitigate failure, we should embrace some level of instability and learn from it. But for teams to be able to truly embrace improving their capability through experimentation and learning from failure, they need the support of their leadership team to give them the time, the space, and the reassurance that they need to understand that some instability is inherent with experimentation, and that they, as a leadership team, believe that the engineering team can figure it out, and incorporate that learning back in their capability to do the work. And with time, they'll begin to see that not only have they improved their capability to do that work, but they've stabilized their quality to levels like before, if not better, but also they've improved their speed. And they've done this all sustainably without resorting to working harder. Now, these two models for working harder and working smarter are actually taken from a research paper called Nobody Ever Gets Credit for Fixing Problems That Never Happened, which appeared in the 2001 California Management Review Journal. Now, to be fair, they were focused on manufacturing, but the concepts of working harder and working smarter very easily translate across to building software. and other types of what we may call knowledge work. Now, an interesting aspect of working harder and working smarter models is that they are self-reinforcing and can become the default ways of working in most teams. The reason for this is that once people start working harder, their capability to do the work begins to be eroded, and therefore, the only way to continue performing is to work harder still. While if they adopted the working smarter model, they would have successfully improved their capability to perform, and then they'd have more time to devote to the capability improvement process, which continues to reinforce that behavior. Now, the work harder loop is not all bad. In short bursts, it can help for handling those unpredictable, unplanned, urgent issues. But if those urgent issues are happening quite regularly, then there's a good chance that the team falls into the trap of always working harder. Now, the working smarter loop isn't all good either, because the more complex your work is, and building software tends to be quite complex, the longer those capability improvement tasks are likely to take. The failure rate is likely to be higher, and the overall improvement could be much harder to measure. So, how do you work smarter? Well, working smarter is all about improving our capability to do the work. And in particular, it's about smoothing the flow of work through our teams by removing bottlenecks. But to be able to do this, we need our teams to adopt a learning mindset that allows us to learn while doing the work. And one of the best ways to do that is through experimentation. But taking an experimental approach to our work doesn't come as naturally to people as most would think. Simply asking people to experiment more might work, but I think we can be a little bit more deliberate here and help people experiment more effectively through collaboration. Now, this is where leadership at a team level is vital, and is what I mean by support from leadership, as they have the greatest influence in setting their direction and helping the teams adopt a more experimental approach to their work. And team members also have an important part to play here too. So, to start, there are 5 key areas most teams need to focus on. The first is positively framing the work. Second is showing fallibility. The third is establishing psychological safety. The fourth, helping team members work across discipline boundaries. And fifth, helping team members learn from failure that will inevitably occur from all those experiments. Now, what these 5 behaviors do is encourage people to share and learn from each other, which is exactly what we need when we're experimenting and heading towards working smarter, not just harder. Now, I've only scratched the surface with these behaviors and how they help you to experiment in teams. If you're interested in learning more, then I highly suggest checking out this book, as it goes into the details of what these behaviors are and how to start applying them to your teams. Three, 2, 1. There's another aspect we need to consider too, and that is, what does speed and quality mean? What you tend to find is that the definitions of speed and quality are very open to interpretation. What is fast for me might be slow for you, and what is a high quality bar for you might be a low one for me. So this means measuring speed and quality can be very difficult, and therefore knowing if you're working hard or smarter even more so. Now, luckily for us, a lot of research has already been done into this, in particular by DORA, or DevOps Research and Assessment Program, which has spent about 6 to 8 years researching what practices and capabilities help drive high performance in software teams. Now, if you haven't heard of this or read in their papers, I highly recommend you do so, as I'm only going to touch on a small, but from my perspective, very significant part of it, which is the 4 key measures they identified as good proxy measures for your speed and quality. Now, the terminology used is a little bit different. Instead of speed, they use throughput, and which they recommend measuring delivery or change lead time and deployment frequency. And instead of quality, they focus on stability of the software system deployed, which they recommend recording your mean time to restore service and change failure rate. Now, these aren't the most self-explanatory, so I like to think of them as questions instead. For lead time, how long does it take you to go from code commit to running in production? And for deployment frequency, how often do you deploy small batches of code to production? Why both these measures are not just one? Well, lead time tells you how quickly you can make a change and get it through your build process, whereas deployment frequency tells you how often you're deploying. Now, for me time to restore service, how long does it take you to restore degraded end user service? And degraded end user service is anything that stops your users from carrying out a task and you have to remedy that problem. Now, the great thing about this measure is that it's embracing failure and says we know issues will occur. So how quickly can you resolve those issues and get your system up and running for your users? And finally, change failure rate. What percentage of deployments result in degraded end user service? While we want to embrace failure, we also want to be doing our best to make sure we're not intentionally causing more problems by deploying too frequently. So this lets you know if you're regularly pushing out a dud release to your users. So how do these 4 metrics relate to working harder and working smarter? Well, working harder will be focusing on throughput and stability as separate things to achieve and seeing them as alternatives. It's either one or the other. Alternatively, working smarter will be looking at these measures in a much more holistic way and trying to get a better understanding on how your team is performing and trying to get to a point where you're going fast and producing a quality release, but in a sustainable way. Now, as a team, by agreeing to use these measures and using the same terminology, it allows you to remove some of the ambiguity I mentioned earlier about what does fast mean and what does quality mean. Now, these measures are by no means perfect, but what they allow us to do is reduce some of the uncertainty in the way we work, which means we can make much more informed decisions based on data rather than just intuition or expert opinion alone. And what this means for software teams is that the conversations are much more focused towards working smarter and seeing what can be done to improve their capability to do the work. Now, we can still use the working harder loop, but for when it's really needed, and always defaulting back to working smarter and looking to learn why you needed to work harder in the first place. You also now have a set of measures that tells you how successful you're being at improving your ways of working and the systems you're building and maintaining. So, the natural question that follows from this is, how do you get started? So, assuming you have nothing at the minute, a good place to start is with throughput, as this measurement covers your whole delivery process. And so getting a good team understanding of how this can help everyone can see how they can contribute towards delivering value. And one of the simplest measurements to understand is deployment frequency. Now, you really want to do this as a team, not just delivery or engineering going off, figuring it all out and presenting it back to the team. If you do this as a team, it builds buy-in from the start and helps everyone develop their understanding together. And to start, keep it simple. Start with just finding out how often you're deploying to production. And you can usually do this simply by just looking at your release notes for the last 6 to 9 months, or just start recording from now. See, when you're starting out, knowing down to the last minute how often you're deploying isn't going to be all that helpful. And all this conversation around what's small and what's a batch, well, it's going to be a distraction. You can start looking at that level of accuracy once you start improving your frequency of deployment. So, you've got some data, present it back to the team. Now, I've left code in. What we tend to find is that teams get hung up on pushing features to production. And so incorrectly believe that deployment frequency is all about pushing more features. But it's about pushing code to production. Now, some of that code could be features, and some of that code could be active. What we want is getting the team used to pushing to production regularly, repeatedly, and consistently. Now, that you've got some data and a team understanding what the data shows, you can start looking at how you can work smarter. And a great way to do that is to use the 5 focusing steps from the theory of constraints. So let's take a quick look at each of these steps in turn to understand how they can help you work smarter and improve your throughput of code and deployment. So step 1, identify your system constraint. So you've partly done this by looking at deployment frequency. But what is it about your deployment process that is causing the biggest slowdown? Or what is constraining your ability to deploy more frequently? Remember, it's about deploying code, not features. Now, the best thing to do here is to model your deployment process as a team. And a simple technique is to ask everyone on the team to create a mind map of how they think the deployment process works. Then, each person does a show and tell, while you simultaneously create a new mind map, which is made up of all the ideas of each person. And what this will do is give you a model of how your team thinks their deployment process works, and helps you identify what parts of the process is constraining your deployment frequency. Now, if you're interested in learning more about how to model your team's process, then I highly recommend checking out this TED Talk by Tom Wujek. In it, he describes a process on how teams can model their ways of working using Toast. Now, I know that sounds a bit weird, but check it out. It's a great process. It's only 10 minutes long, and it will really help you model your team's way of working. From there, move on to step 2 and 3, which is all about exploiting the system constraint and subordinating everything to it. This is all about looking at the low-hanging fruit in your process. What can you do right now that would improve the constraint without changing the existing process significantly? Exploiting is all about making quick improvements to the existing process and making the most of what you have right now. Subordination is all about reviewing all the processes that feed into that constraint that you've identified and making sure more work isn't going into that constraint than it can handle. Step 4, elevate the system constraint. If the constraint remains even after exploiting it to its full potential and optimizing all the parts that feed into it, then you can start looking for ways to radically improve that constraint through experimentation. And a great technique for this is using something known as the crazy eights. Now, I won't go into the full details of this here, but this is a great way for teams to come up with lots of different ideas very, very quickly. Then, once you've got your ideas, you can use an impact effort matrix to work out which of those ideas will give you the highest impact, but with the lowest possible effort. Then, it's all about running those improvement ideas as experiments by using the principles of experimentation collaboratively from earlier, and you keep working on this until this constraint has been mitigated. Now, I'll provide some of these links for crazy eights and impact effort metrics at the end too. Step 5, do not allow inertia to cause a system constraint. This step is all about making sure you don't just stop and go back to business as usual. Now that you've proven out the approach and made releasing faster, you can start looking at improving your accuracy in your measurements and start the process over and see where the constraint has now shifted to. Because the constraint will move. It's like a balloon. If you squeeze the middle, it'll do one of two things. It will, 1, burst, or 2, squeeze the air to the east side of it. So you now have to work on where the constraint has now shifted to. So, are we now working smarter? Well, what have we actually done? We've got a team understanding of what throughput means and specifically focus on deployment frequency. We've got a way to get that data and a technique, the theory of constraints, to improve our capability through experimentation and learning. So we've got most of the parts on how we can work smarter. But we're still looking at throughput and stability as two separate things. Which means that while we successfully found a way to improve our speed, throughput, there's a very good chance that we sacrifice quality or stability. Potentially, what we're doing now is something that my colleague is really fond of saying. We're shipping, you know what, slightly faster. So how do we take a more holistic approach to throughput and stability? So this is where the idea of metrics and tensions come in. Once you get a handle on what your deployment frequency is and how you can improve it, it's a great time to start looking at your stability of your product, and specifically, change failure rate. Again, this can be done manually at first. Look at the number of releases you made, what percentage of those resulted in end-user facing issues. But remember, those are issues experienced by your users that you had to fix, not issues you caught before releasing to your users. And what this can do is act like a countermeasure and help you understand if your improvement efforts are just working harder or actually working smarter. So, to summarize what we covered here today. Working harder is focusing on doing the work, in some cases by any means necessary, as fast as you can. While working smarter is doing the work, but focusing on improving your capabilities to do that work through experimentation in a supportive environment, slowly and steadily and iteratively. But in order to work smarter, you need to shift from a purely execution mindset and towards a learning mindset. One that is focused on learning through experimentation, that embraces the inevitable failures that occur and collaborating with your teammates. Now, to help drive that mindset, we need to shift our mental models that simply view speed and quality as opposite ends of the spectrum and starts to view them as two sides of the same coin, which is delivering value to our users. But speed and quality are highly subjective. So, in order to build a common understanding, you can use the DORA key metrics of throughput and stability. Then, to get started with working smarter and learning while doing through experimentation, you can use the theory constraints to work on the highest value areas for your team. And then use metrics intention to take as much of a holistic approach to working smarter and start viewing it as speed and quality. So, to finish, and back to my original question, can you have both speed and quality? Yeah, I believe we can. And by taking time to understand why we think we can't, we can start to see ways towards how we can. And maybe, in calling it working smarter, let's just call it what it is. It's continuous improvement. And with that, I have one question for you and all your teams. How are you working towards continuous improvement and not just working harder? So, here are some links, some papers and reports and techniques I reference. You can also find it in this note on the right of the screen, and if you're interested in learning more about any of these topics, then check out my newsletter. And thank you all for listening to me today. We might have time for some questions, but otherwise, thanks very much, everyone.